What is NDE? Non-destructive examination and test methods explained. Welding Inspection Mastery, complete NDE NTT course. Gary Pace, PE, welding engineer, Katy, Texas.
We're going to talk about non-destructive testing in this course, and this first module, we're just going to take a little quick overview of it and kind of get an understanding of what we're talking about. So, non-destructive tests, pretty much what the name says it is. We're going to test things for cracks, discontinuities, or other flaws without damaging the part. So where we see this in everyday life would be an X-ray, or use an ultrasound to check out a baby inside of a woman to see, it's got all its toes and it doesn't have like claws or wings or, you know what I mean, spawn of the devil or whatever, right? So you can see these things in everyday life where the general idea is we're using a testing medium to find information about something and without destroying that part. So that's what we're talking about with non-destructive testing. So the main testing methods that we're going to talk about, and I'm a welding guy, so we're probably going to skew in that direction a little heavier. So the main methods that we're going to talk about are used to locate holes, cracks, breaks, other flaws or discontinuities in materials or other articles. So the ones we're going to look at are liquid penetrant testing, mag particle testing, radiographic testing, eddy current testing, ultrasonic testing, and not listed here is visual testing. We're also going to touch base on that one.
So why does NDE matter in industry? Well, big one is it should help prevent failures before we enter things into service. We're going to use this in pipelines, pressure vessels, structural steel, all kinds of places. Shutdowns are going to hopefully be less costly when we do them. We can do repairs. Also, in this day and age, we don't want to be putting things out in the ocean and having them fail. That gets really expensive really quick. Go back about 15 years ago, Gulf of Mexico, BP, the Macondo, Deepwater Horizon event, just as an example. And not that that was a weld failure, but think of all the millions of welds that are underneath the Gulf of Mexico. So you got to do it right. So that's why NDE matters. Or, on a grander scale, you don't want a Chernobyl happening on American soil or wherever there is a nuclear power plant, or having a gas release from some kind of chemical factory. So, but anyways, that's why we care.
So for the 5 methods other than visual that we talked about, I pulled this out of a military manual, and you can see where they're explaining the non-destructive test methods, and we've got a definition of what it is, uses, and then the limitations. All of these have limitations, and we'll get into that here in a little bit. So, for the 5 processes, liquid penetrant testing. It uses a penetrating liquid to seep into a surface discontinuity, thus providing visible indication. Okay, so you can use it on metal, glass, ceramics, other discontinuities. It's simple. We don't need a lot of equipment. And the limitations. We can't find anything beneath the surface. So all of these processes, these non-destructive testing processes, have their strengths and their weaknesses, when they can be used and when they can't be used, and what kind of flaws that they can find. No one of these is perfect for every situation. So just that's what I'm trying to get across here as we go through this course. So with destructive and non-destructive tests, as I said, non-destructive tests are essential to supplement destructive tests. So in welding, a lot of times we'd use a non-destructive test, to find a flaw in a weld or some other material. Well, that's because we can't be out there testing welds and destructively testing them. So we'll use non-destructive testing to help us out. But destructive tests, we're going to bend something, break it, twist it, and destroy it and just wreck its usefulness for service to see what mechanical properties or chemical properties or whatever material properties that test sample has. Well, if we want to put something into service, we can't destroy it and then expect it to work well. So since these tests destroy the article, we try not to use destructive testing unless we have to. So generally we only do destructive testing a little bit, especially in welding. We'll do destructive testing right off the bat when we qualify a procedure. But once something gets put into production, especially if it's a bridge or a structure, we don't generally cut out welds and destroy them to see if it's a good weld. We'll use non-destructive testing for that. So with non-destructive tests, we're going to go in there and look at things, and the key is we don't want to alter or change the physical makeup or properties or qualities of that component or structure. We're just looking at it and saying, yeah, this is good. We don't want to go in there and wreck the bridge just to see that, yeah, we built a good bridge. Kind of defeats the purpose and gets costly. So when we do non-destructive testing, we can inspect something without damaging the physical structure or how that component is going to function in the grander scheme of things. This is why we do non-destructive testing. In the medical field, if we want to look at somebody's heart or kidneys or something, we might use ultrasonic testing to go in there. We don't have to get a scalpel and, sedate the patient and go digging around with a knife and some pliers or whatever instruments surgeons use. Yeah, your kidneys are shot. Well, yeah, we've destroyed it in the process, but, it was messed up anyways. No, we use a non-invasive procedure to gather data that we can utilize to make decisions on whether we're going to fix a weld or whether we need to go in and fix a kidney or replace it or whatever. So that's the idea behind non-destructive testing, is looking at something, gathering data without destroying it. So this is when non-destructive tests supplement destructive tests and give further assurances that all articles meet our quality standards. That's what we're looking for. So when we use the word discontinuity, we got to have some vocabulary. We're going to do a little vocabulary building right here. A discontinuity is a break or interruption in the normal physical structure of an article. So that doesn't mean that it's necessarily a defect. It just means it's a discontinuity. It means the normal physical structure is not there. So we're going to have to look at it and figure out, and compare it to something. There's got to be some kind of criteria that we can use to decide if this is, indeed a flaw that needs to be repaired. Is it a defect, or is it just an aberration, a break in the interruption of the normal physical structure, a discontinuity? And discontinuities in metal, like I said, I'm a welding guy for the most part. It can be a hole, a crack, a flaw, or anything that breaks the continuity of the metal. That's what we're talking about. So it's just something that isn't in that normal physical structure. So that's what we call a discontinuity. All defects are discontinuities, not all discontinuities are defects. And we can have discontinuities in either the surface of the metal or within the metal itself. So once we get into discussing how we're going to find these things, we got to know what we're looking for. Are we looking for surface defects and discontinuities, or are we looking for subsurface discontinuities and defects? So the word discontinuity, flaw, and defect. So within welding inspection, so we got the terms discontinuity, flaw, and defect. So here's some more definitions. A discontinuity is an interruption in the typical structure of a weldment. So it could be, it's consists of a lack of homogeneity in the mechanical or physical characteristics of the base metal or weld metal. Key here is a discontinuity is not necessarily a defect. Just because it's not normal doesn't mean it's a defect or it's going to be a problem. So we need to keep that in mind. A flaw is nearly synonymous with a discontinuity, but has the connotation of undesirability. So a flaw is something that is a discontinuity, but it could be undesirable depending on what we got going on. And then a defect is a discontinuity by nature or effect renders the weldment unable to meet the specification or acceptance standards. The term designates rejectable condition. So discontinuity does not designate something as rejectable, whereas defect, something like a crack, which is a defect, makes the part unusable, and it also designates it as a rejectable condition. We can't use it. It's a crack. We can't use it anymore or at all. So discontinuity, flaw, and defect.
So here's a list of things that we could reasonably expect to find if we're doing non-destructive testing on welds in this case. We got the laundry list: porosity, slag inclusions, maybe tungsten inclusions, undercut cracks, all of this stuff. We can find these things with our various toolkit of non-destructive testing methods. And that's why we use non-destructive testing, is we can go in and find things and not have to rip something apart. And we can do it and do it relatively cheaply.
So here's some more definitions and general descriptions. Non-destructive examination is, we're going to use this term to designate inspection methods that allow materials to be examined without changing or destroying their usefulness. It's a way for us to look at something without wrecking it. That's the term we're going to use going forward. Non-destructive examination. Non-destructive testing and non-destructive examination, to me, they're the same thing. And then you've got another one, non-destructive NDI, non-destructive inspection. All these terms are pretty much interchangeable, and they're generally within the universe of non-destructive testing, non-destructive examination. They're all pretty much considered synonymous with each other. There isn't, that I know of. And I'm, like I said, but I'm a welding guy. Maybe there is some deeper rooted definition further down a rabbit hole. But for me and for the rest of the normal world, whatever that is, these terms are interchangeable. They're synonymous with each other. So NDE examinations, we do them on welds and materials, once again, to verify weld quality or material quality meets the specification. And we can also use them in service to determine if weld quality has degraded during the service time, the amount of time that component or structure has been in service. So we can use non-destructive examination for initial inspection, but also in service quality control inspections to determine whether or not a part is still usable or not. So when we do an NDE method, they must include the following to render the examination results valid. We got to have a trained operator. You just don't want to turn somebody loose. You hired a new guy last week. He was flipping burgers at Burger King, fine restaurant chain. And now you're making him the guy that's making the decisions on whether welds are acceptable or not acceptable. And he has zero training outside his career as a burger flipper. Well, you're going to need a trained operator in that method who is conversant in that method and also in the possible defects that could arise from welding and materials manufacturing. We want to have a procedure for conducting tests so that night shift person and day shift person are doing the tests the same way. Or if we hire a new person, a third person to go with night shift person and day shift person, all three of them are doing the tests the same way. We don't want a situation where night shift person is using their super special secret recipe to do the non-destructive testing, and we're getting completely different results from them than we are day shift person or our third person. We want to have a system for reporting results. How are we going to report these results so that we can, rectify whatever situation has come up and needs to be repaired? We need to figure that out. We also need a standard for interpretation of the results. All right, we got a procedure for conducting the test, but what's the standard that we're going to use to interpret the results? That's one thing we need to understand. Okay, which flaws are rejectable? Which discontinuities are flaws and thus rejectable and unusable? And which ones are acceptable? We need to have some kind of standard for acceptance criteria. So once again, we talked about the commonly used NDE methods. So we've got, visual inspection, with or without optical aids, liquid penetrant, mag particle, radiography, ultrasound, and eddy current testing. These are the common ones that we're going to talk about. There's other ones that are way more specialized, but for the normal universe within welding and materials manufacturing, these are the big ones, the most common utilized non-destructive test methods.
So no single NDE method is going to find every discontinuity. Each one's got a Achilles heel, so to say, a soft spot, things they can't do, things they do really well, and things they don't do really well. And this is going to boil down to, the geometry and the service conditions. If we use the wrong technique, we can have false indications, false positives or false negatives. Some inspection methods, you really have to have inspectors that are really skilled. And the procedure quality is going to matter. Who's doing this? How good are they? And not every discontinuity is a defect. And being able to determine that's kind of a skill in and of itself. So NDE does support quality control. It does not replace good welding practices in the real world.
Questions, comments, thoughts, concerns, Gary A. Pace, PE, CWI, Katy, Texas, TexasWeldingEngineering.com, gpacex@gmail.com if you wanted to track me down and chat.